We're going over the daily work on Unit 1-3. We want to name angle Q two other ways. Remember, you can name an angle by its vertex if it's the vertex of only one angle. Or you could use a point on one side and then the vertex and then the point on another side. So we could call it angle ZQE, or you could start the other way, start from E. If there was a number in the corner like 2, we could call it angle 2, but there wasn't. So that's not an option to put on the line there, okay? Remember, by definition, an angle is a figure formed by two rays with a common endpoint. The two rays are called the sides, and so the sides of an angle are the rays that form that angle. So one of the sides is ray QZ, and you can write down the other one. The common endpoint is called the vertex, and so the vertex is point Q, that common endpoint, and you can finish that. Okay. Looking at the diagram to the right here, we want to name 4 acute angles, 3 right angles, 2 obtuse angles, and 1 straight angle. Remember that the separating concept is visually is straight over, straight up, because a right angle is straight over and straight up, so that the two sides are perpendicular, we would say, to each other. Now, anything less than that straight over, straight up concept is acute, and anything greater than that straight over, straight up concept is acute. And we really should be saying, you know, between 0 and 90, exactly 90, between 0 and 180, and exactly 180. But there may be a little difference in how we define it and how we visualize it. So one angle that is less than straight over and straight up would be this angle right here. And we can name it from a point on one side and then the vertex and then a point on another side. And so there's one acute angle, angle JYZ, and we'll let you find the others. One of the right angles is this straight down and straight over. We could start at H, go to the vertex Y, and over here to Z, and so we could call that one angle HYZ, and you can find 2 more in that picture. You may have to add up some stuff to get there, you know. An obtuse angle would be more than straight over and straight up, and we could start right here and go more than straight over, straight up, all the way over to here, and that would be an obtuse angle. So we could start with a point on this side, R, and then the vertex Y, and a point on this side, Z, angle RYZ. And you can find another one. You may have to start from the other side to find it. And then a straight angle is exactly 180 degrees, and you may say, well, how do you name that as an angle? Well, an angle is a figure formed by 2 rays with a common endpoint, so Y could be my common endpoint, and we could have the ray from Y to X and then the ray the other way. And so we name an angle by a point on one side, one ray, right? And then the vertex, and then a point on the other side or the other ray. And so we could call that one angle XYZ. Those are called opposite rays, right? Those 2 opposite rays, ray YX and ray YZ, form the straight angle, angle XYZ. Okay? Now, what we're getting into here with the next little picture is dealing with angle addition and angle subtraction and the definition of an angle bisector. So if we were going to add 2 angles, we would say, okay, I'm starting with angle AGB. So that would begin with A. tried to throw you off. See, you thought I was going to bend at A, didn't you? But we're not bending at A. We're bending at G because G is in the middle, so that's got to be my vertex. So we're starting at A, and then we're going to G, and then we're going to B. So this is the angle we're talking about right here that bends right here, see? Because the vertex G is named in the middle. And then the other angle is angle AGF, which is from here to here to here. A first, then G in the middle, and then F. So we're talking about this. And together, those two angles, whose vertex is G, would go together to form this whole big angle. And we would name it from a point on one side, vertex in the middle, and a point on the other side. And so they would create angle BGF. And what we're using is what we call the angle addition postulate. Angle addition postulate. And just like we can add angles, we can subtract angles. There's not an angle subtraction postulate per se, but we could call it angle subtraction if we're subtracting, just like we call it angle addition if we're adding. Now, number 10 says ray AH bisects angle DAE. Let's just look at ray AH. It starts at A and goes indefinitely through point H. It says that it bisects angle DAE. So we would have a point on one side, the vertex A, and a point on the other side, E. But remember, an angle actually goes indefinitely forever. Therefore, its bisector has to be a ray that goes indefinitely forever. Now, an angle bisector is a ray that divides an angle into two equal adjacent angles, or congruent adjacent angles. And so we can say that ray AH bisects angle DAE. Therefore, we can conclude that angle so-and-so, and you can see them in the picture, is equal to angle so-and-so. And remember, we have the word angle bisector, the what we get out of it, two equal angles. So our reason would be definition of that word angle bisector. Definition of. We had the word and what we got out of it. Definition of. Any questions on that? Okay. Now, angle BAH is 140. I'll tell my students generally when I'm teaching geometry, if you're out in your truck and it's muddy and you get stuck, then you crawl out, you put it in four-wheel drive, and then you take off again and you get unstuck. When you're doing geometry and you get stuck, you draw a picture and you label your diagram. Drawing a picture and labeling your diagram when you're stuck in geometry is kind of like getting out and putting it in four-wheel drive in a pickup truck. Now, you can tell I'm a little dated because you don't have to get out and do that on the wheels of the pickup trucks anymore. You can do it from the inside. It's all automatic. But in the olden days, back when I was a youngster, you had to crawl out of the truck to put it in four-wheel drive. But anyway, when you get stuck in geometry, you draw. So it says angle BAH. So we would want to identify that. That means we start at B and we bend at A and we go up here to H. And so that amount of rotation from there to there is 140 degrees of rotation. And it wants to know if that is 140, then how much is this? And we're hoping that you visualize that this is a straight line or a straight angle. And since that's a straight line or straight angle, the two angles in question are called a linear pair. And we know something about a straight angle, and we know something about a linear pair that we would be using to solve that with. Okay? Name two angles adjacent to angle BAG. Angle BAG. Let's go ahead and draw angle BAG. We're going to start at B, bend at A, go to G. Remember, geometry things tell us how to draw what we're talking about. To be adjacent, it has to have a common vertex. It has to have a common side, and we have two choices. Here's one choice. And it can have no common interior points, so none of the points in this one can be in the other one. In other words, our new one can't overlap that one. So it has to have a common vertex, which has to be that. It has to have a common side, which is either here or here. So we got more than one choice. If we choose the green, then it can have no common interior point. So the nearest, or the smallest, I should say, angle adjacent to angle BAC would be this angle right here, which is angle CAF. Now, I only said to name two angles adjacent to that, but there's more than two, because we could go all the way to here and that would be one, or we could go all the way to there and that would be one, or we could go all the way to here and that would be one, or we could go the other way, right, with that other common side. So there's lots of possibilities of angles that are adjacent to angle BAG. Okay? Now we're getting into drawing and labeling, and this is a little bit difficult for me to do exactly, and so I'm going to kind of hand draw some of this to help you have a visual of how I want this done. It says ray AB bisects an 80-degree angle. If we were going to draw an 80-degree angle, then we would begin with a ray. Because an angle is a figure formed by two rays, we call this beginning ray the terminal side, and we could take a protractor where this is 0, and this is the little hole in the protractor, or the little point on the protractor. Sometimes they have a hole in them, and sometimes you set it flat on there. And then your protractor would do this, and this would be 180 degrees. And so we would think about our angle in standard position, where theoretically this is the XY axis of a coordinate plane, and the little bullseye is on the vertex. And we've made the initial side of the angle be setting at 0 degrees on the protractor. And if we want it to be 80 degrees, we look at the ditto marks, 10, 20, 30, 40, 50, 60, 70, 80, 90. And we'd go over to wherever 80 degrees is. Let's just say that it was right in here somewhere. And normally what you do is you just make a little mark on your paper right above your protractor. And you then move your protractor and take a ruler, and then you connect. And if we wanted to have bisected it, not only would we have done that, but we would have put a mark on 40 degrees, which is halfway, and we would have marked that too. That's if we do it all with a protractor. And so we could have this ray, ray A, B, that bisects angle C, A, D, and we would know that these were both 40 degrees. And so angle CAB, this angle, is 40 degrees. Okay? Now, this may be a little bit challenging for me to model, but let's say you actually did get that 80-degree angle drawn, and you forgot when you drew that 80-degree angle to bisect it. Now, what we can do is take a protractor, a compass, excuse me. I'll probably say that wrong more than once this year, so you can begin forgiving me right now. This is a pencil, and that's the little pokey dilly. And what you would do is open it up a little bit, and you would put the pokey part right here, the pointed part, and you would open it up to the pencil part hit there, and then you would rotate it so that the arc hit the two sides of the angle at a certain point. And then you would open up your protractor again so that the pointed part was here and the pencil went over halfway, and you would make an arc out here. And then you'd put the pointed part on this side and make your pencil make an arc that way. And then you could go from the vertex straight through that intersecting point, and that's how you use a compass, to bisect an angle. So we could have drawn our 90-degree angle, or our 80-degree angle with our uh, protractor, and then we could have taken our compass and done that arc work to bisect that angle, okay? All right. We'll let you play with 14 and 15. We're going to do some of these word problems down here. Now, if you used my Algebra 1 book, then on page 40 it tells us how to do word problems. And I would have my students write characters and word sentences. And so we would look at this and say angle 1 and 2 are adjacent angles that form a straight line. In other words, they are a linear pair. And so for my algebra students, we would say, that's a formula word, because we know that a linear pair or a straight line is 180 degrees. And so I could write an equation, something plus something is equal to 180 degrees. So I would have put that concept on a formula word line, and I would have written the equation that pops out from that. And then we would have kept reading, and then it says angle 1 is twice as large as angle 2. Now, again, I'm quoting page 40 of my Algebra 1 text. Page 40 of the Algebra 1 text, which you can find online at www.dballardproductions.com. But if you do that, then we would have said on page 40, when we're trying to write out word sentences, they can be a comparison between two characters, and that's what this is. Angle 1 is twice as large as angle 2. It compares two things. Or we could have formula words like perimeter, area, volume, circumference, linear pair, y equal b plus mx, and on and on and on with formula type stuff. And then we could have sentences containing words like total, which means add, or sum, or difference, or product, or quotient, things that mean add, subtract, multiply, or divide. So we would have identified in Algebra 1 class on page 40 of the algebra text that this is a comparison between two characters, and so we would put angle 1 is twice angle 2. And we said in algebra that what we wanted to put on our word sentence line were the two variables that we were comparing, the two characters, angle 1 and angle 2. The verb, like is, was, has, did, ran, won, etc., because that means equal. And then any word that means add, subtract, multiply, divide, like more than, less than, increased by, twice, double, half, those types of things. And then we would have written characters, and the characters of our story, modeling the Algebra 1 text, would have been angle 1 and angle 2, which we've obviously called angle 1 and angle 2. So right here where it says subject verb, we would have said we're going to put subject equal because the verb means equal. Twice means you multiply by 2, and so we would have 2 times angle 2. So angle 1 is 2 times angle 2, and I'll put a dot just so we see that that's multiply. Sometimes in geometry, we'll go ahead and put parentheses a lot of times with the angle just so we show our multiplication that way. And then over here with the concept of the linear pair, we know that angle 1 plus angle 2 is equal to 180 because a linear pair is a pair of angles whose external rays form a straight angle, and a straight angle is 180. So a linear pair adds up to 180. What we're going to do is we're going to substitute, because we learned on page 42 of the algebra text that you can't solve with two variables. If you have two variables, you need one named in terms of the other, and if you have one named in terms of the other, then we can substitute to get down to one variable. So since angle 1 is equal to 2 times angle 2, we're going to replace the angle 1 with the 2 times angle 2. And we would have 2 times angle 2 plus angle 2 is equal to 180 degrees. Once we're down to one variable, then we can solve using the order of operations horseshoe, which is on page 33 of the Algebra 1 text. And in that we say, is there anything we can do to simplify in the order, please excuse my dear Aunt Sally, looking for distributive property and combining like terms. And let me get this out of the way. And so we're going to combine like terms, and we would have 3 angle 2's is equal to 180 degrees. Now we're going to undo multiplication by division to isolate, and we would get angle 2 is equal to 60 degrees. If we wanted to find angle 1, we would substitute the value we found for angle 2 in its place in this equation. We would have that angle 1 is 2 times angle 2, which is 60 degrees. So angle 1 would be 120 degrees. So angle 1 is 120 degrees. Angle 2 is 60 degrees. There are two angles that are linear pair, meaning the sum of their angles is 180, and angle 1 is twice as large as angle 2. So we can see that that particular answer satisfies both parts of that word problem. Any questions on that? If you're not real good with word problems, you might study page 40, 41, 42, and the algebra book a little bit. If you're not good with solving using the order of operations, you might go back and study the horseshoe on page 33 of the Algebra 1 text. Okay? And we'll leave the rest of